again, it would be helpful if you could memorize the first 3 terms of each common Maclaurin series, so you don't have to figure it out on an exam or quiz. Okay, so now I want to plug in. So I have x minus tan inverse, which I just have here. Okay, so I plug in these terms. So x minus x to the third over 3, plus x to the 5th over 5, minus x to the 7th over 7, and so on. And then I divide by x to the third times cosine, which was 1 minus x squared over 2 factorial, plus x to the 4th over 4 factorial, minus x to the 6 over 6 factorial, and so on. Okay? Any questions so far? All right, so now I have x minus x, so those two cancel out and just get 0. And then I can just distribute this negative sign to all the rest of the terms. So that would give me x to the third over 3 minus x to the 5th over 5 plus x to the 7th over 7 minus dot 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 over, I'll just put ditto, meaning the same denominator as before. Questions? Yes?
Is it supposed to be negative x cubed over 3 plus x to the 5th minus x to the 7th?
I distribute the negative sign to each term.
Right, thank you.
Okay, so now our denominator has an x to the third. And so our numerator, okay, we see that the lowest degree is 3. It goes x to the third and then it just increases after that. Okay, so maybe I can cancel out x to the third. So I'm going to distribute out an x to the third in the numerator and then cancel it out with the denominator. So I have a limit as x approaches 0 of x to the third. And then I multiply by the rest in the numerator. 1/3 minus x squared over 5 plus x to the 4th over 7 minus dot 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 over the same denominator, x to the third times 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on.
Are you able to multiply it by x to the third? Oh, never mind, just pulled out this grade.
Okay, so now the x to the thirds cancel, and I'm just left with the rest. So I have the limit as x approaches 0 of 1/3 minus x squared over 5 plus x to the 4th over 7, and so on, over 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. Okay? And so now I just do direct substitution. So I plug in 0. So I have 1/3. Now I get minus 0 plus 0. And I know for every term after that, the exponent is just going to increase, so they're all just going to be 0. And in the denominator, I have 1 minus 0 plus 0. And I know every term after that, the exponent is just going to increase, so they're all just going to be 0. And so now we find that the limit is 1/3. Okay? And so we were able to do that using series. We didn't even need to touch L'Hopital. Cool, huh? Or you can even just use series to check your answer. Okay? I think it's much neater and cooler and cleaner than L'Hopital when you can use it. Questions?
This is like a general rule. How do you know when to like write out the terms? Like write out the first few terms or just put like the general form?
Okay, so usually you want to write out the terms if you can see that you're going to be canceling out terms. See, like here we were able to cancel out these terms, so it's better to write out the first few terms. Okay, but in the first example I did, the integral of cosine over x squared or whatever, we weren't able to really cancel out terms there, so it's probably just easier to use in summation relation. So if you're adding or subtracting like terms, then it's probably better to write out the first few terms. Any other questions? Yeah.
How come the negative? How come you distribute the negative?
Here?
Yeah. Because I know like there's a negative, like the negative.
Because all of these, we have to distribute negative to all these terms.
How come you, well, then in the problem before you didn't distribute the negative, even though it was behind it?
The problem before, which problem? For the integral?
It was like sine of x minus x. So like it was behind it, so you didn't distribute the negative.
Because the negative sign was after?
Is that why?
Yeah, because, is that what you're asking? What?
I guess that's what I'm
Yeah, because the previous example, it was like this, right? So there's no negative sign in front of parentheses here, it was here. So there, we can't distribute the negative sign if we're subtracting x from this whole thing. If it was over here, then we would distribute the negative sign, but it's not. Does that make sense? It was like if say this was 5, we have 5 minus x, okay? But over there, we had x minus 5, so we distribute the negative sign there. Here, we don't put a negative in front of 5 because the negative is in front of x. Make sense? Any other questions? Okay, so now we see how Taylor series is useful.